Today we are going to tackle a challenging problem, finding the fifth root of complex expression. After seeing the fifth root, usually what we do, we assume this complex expression as some other variable like x and then take the fifth power of it and try to solve it. We can follow this way, but here is the twist. I'm not going to use this approach. Instead, I will be using only math hacks that will be super helpful in our competitive exams. So, let's dive in and explore how to crack this problem using some clever math tricks. So, what the given expression fifth root of 41 plus 58 over root 2. At the denominator we have root 2. So, to simplify this denominator, I'm going to do multiply and divide by root 2. Then the denominator root 2 times root 2, which is 2. Let's take it 2 here. So now 58 over 2, after cancelling this, you will get 29. So let's write here 29. Now we have fifth root of 41 plus 29 root 2. And we know that root 2, the value is 1.414. Let's take that. And here we have 29 root 2. So let's both sides multiply by 29. Then you will get 41.006. So 29 root 2, the value is 41.006. Let's take that. 41.006. After adding these two, 41 plus 41.006, we will get 82.006. Now we need to find out this fifth root of 82.006. But it is in a decimal form. If you convert this decimal form into a fraction, then it is easy to find the fifth root of this number. So that's why I'm converting this as into a fraction. This number 82.006, we can write this as 82 plus 0.006. 0.006, we can write it as 6 over 1000. Our question is fifth root of this number, isn't it? At the denominator we have only 3 zeros. Suppose if we have a 5 zeros, then you take the fifth root of this number, then you will get only 10. So but at the denominator we have only 3 zeros. That's why I am trying to convert into fifth root of this 100,000. Then I can simply write this as 10. That's why I am multiplying and dividing by 100. 6 times 100, which gives 600, over 1000 times 100, which gives 100,000. That means we are getting here 5 zeros. After taking the LCM, we get a denominator 100,000, that is 5 zeros, and numerator we got 82 5 zeros plus 600. This is fifth root. After adding these two numbers, then you will get fifth root of 82,00600 over 1 5 zeros. So now it is in the form of square fifth root of a over b. We can write this as fifth root of a over fifth root of b. So we can write this as fifth root of 8,200,600 over fifth root of 150. The denominator simply we can write this as 10, isn't it? Now our goal is to find fifth root of 8,200,600. Let's go and see how to. For that, let's take 2 raised to the power of 5. What is the value of 2 raised to the power of 5? 32. 2 raised to the power of 5, the value is 32. Suppose if you take 20 raised to the power of 5, that means 32, and we need to add 5 zeros, isn't it? 1, 2, 3, 4, 5. That means 20 raised to the power of 5, the value is 3,200,000. Suppose if you take the 3 raised to the power of 5. So what is the 3 raised to the power of 5 value? 243. If you take 30 raised to the power of 5, the value is, just write 243 and add 5 zeros. 1, 2, 3, 4, 5. So this is 24,300,000, isn't it? So this is 20 raised to the power of 5. The value is 3 million. 30 raised to the power of 5, the value is 24 million. But our given question is 8 million. So that means our number 8 million lies in between 20 raised to the power of 5 and 30 raised to the power of 5. So but we don't know where it is exactly. So let's take the middle number, which is 25 raised to the power of 5. So 25 raised to the power of 5, that means 25, we are doing multiplication by 5 times. First take only these two numbers, which is 25 times 25. So we can write this as 25 whole power 2. When a number ends with 5, we have a trick to find this number within 1 second. That is, suppose if we have a number 35 whole raised to the power of 2. This number ends with 5. So in this case, the first step is we have to do square the last digit, which is square the number 5. 5 square is 25. Just write it here, 25. And then the second step is take the first number, which is 3, and multiply with this next number. What is the 3 next number? 4. So 3 times 4, which gives 12. So 35 whole raised to the power of 2. The result is 1225. That is 1225. Suppose if we have a number 65 whole raised to the power of 2. This number also ends with 5. So what we do? You have to square the last digit, which we have 5. 5 square, that is 25. And then take the first number 6 and multiply with this next number. 6 next number is 7. So 6 times 7, which is 42. So 65 whole raised to the power of 2. The result is 4225. Our 25 whole power 2 also ends with 5. So let's square the 5. 5 square, which is 25, and take the first digit, which we have 2, and 2 next number is 3. So 2 times 3, which is 6. So 25 raised to the power of 2, the result is 625. Similarly, here also 25, we can write this 25 times 25, which is 25 raised to the power of 2, the result also 625. And these two numbers, the result also 625. So now multiply these two numbers. What we have? 625 whole raised to the power of 2. The 625, we can write this as 600 plus 25 whole raised to the power of 2. It is in form of a plus b whole square, isn't it? So use that formula here. What is the formula? A square, that is 600 square, which is 36. Here we have 2 zeros, so we are doing square, that's why I write 4 zeros, plus b square, that is 25 whole square. We know that 25 whole square, the value is 625. So let's take that 625 plus 2ab, that is 2 times 600 times b25. So 25 times 2, which is 50. So 600 times 50, which gives 6 times 5, 30, and write 3 zeros. After adding all, then you will get 390625. So this is the value of 625 times 625. So we are done with 25 times 25, again 25 times 25. Still we have this 25. So now again we need to multiply this 25. And we know that 25 is nothing but 100 over 4. Isn't it? So instead of 25, I am going to write 100 over 4. So instead of doing multiply by 25, we can do divided by 4, which is very easy. Let's do it. 4 9s 36. The remainder is 3. Add with the next number, which we have 30. 4 7s 28. The remainder is 2. Now combine with the next number, which we have 26. So 4 6 24. 26 minus 24, which gives the remainder 2. This 2 combined with the next number. Now we have 22. 4 5 is 20. So 22 minus 20, which gives 2. So that means remainder is 2. Now this 2 add with the next number. Now we have 25. 4 6 is 24. The remainder is 1. So after next we don't have any number. So let's take the decimal point and add 1 0. 4 times 2 is 8. Let's take and do subtraction. Now you have 2. Because of decimal point we can add 1 0. So 4 times 5 is 20. So that we got this 97656.25. Still we need to do times 100. After multiplying by 100, we will get 9765625. This is the 25 raised to power of 5 value. That means we are getting 9,765,625. So 25 raised to power of 5, the value comes in 9 million. Since our number is between 20 raised to power of 5 and 30 raised to power of 5, we tried 25 raised to power of 5, isn't it? So we tried 25 raised to power of 5. The value is 9 million. Using this calculation, we can estimate that fifth root of 8,200,600 is approximately equal to 24 raised to power of 5. I am not saying exact value, I am saying approximately equal to 24 raised to power of 5. Because 25 raised to power of 5, the value is 9 million. Our given number is 8 million. Using this estimation, we can conclude that the fifth root of our original expression is approximately 24 raised to power of 5. So the numerator is approximately fifth root of 24 raised to power of 5. The fifth root we can write it as 1 over 5. This 5 and this 5 gets cancelled. We left only 24 at the numerator. So 24 over 10, which gives 2.4. So that means the value is approximately 2.4. Our given question is fifth root of 41 plus 58 over root 2. So the given question is in terms of root 2. So if you want to convert this 2.4 in terms of root 2, that is root 2, the value is 1.414. So 2.4 we can write it as 1 plus 1.4. So this we can write it as 1 plus, this value is really equal to root 2. So we can write this as 1 plus root 2. And that's it. We have solved a complex problem using estimation, approximation and mathematical reasoning. Thanks for watching, and don't forget to subscribe for more math challenges and tutorials.